in trinomials when the leading coefficient is greater than 1. So in this case it's 49. So the good way to solve it is by combining methods. So we multiply the leading coefficient by the constant here 1. 49 times 1 is 49. And now we factor this 49 in two factors, and we're looking, can we reach this minus 14? So if I write it, the 49 is 7 times 7, and minus 7 is minus 14. So it satisfies this criteria. And then we can write this 49x squared. We can write this way. And instead of minus 14x, I can write minus 7x and minus 7x, which is a negative 14x. And instead of the three terms, I'm writing here a fourth term, and we are trying to combine now. And now, as we see here, the 49, we can write 7 times 7x squared. So let me make a little bit more simple here, and let's see to find the greatest common factor of these two terms. And I have minus 7x minus 1. So plus 1, I'm sorry. And now I'm taking two terms here. I am factorizing, and I'm going to factorize these two terms here. When we factorize this one, we see we have a 7x both sides is like a common factor. We have a 7x, and inside here remains 7x. So, and in this side here is a minus 1. So 7x is the greatest common factor. 7x times 7x is 7 times 7x squared. 7x times minus 1 minus 7x. So it's a good. And here we are factorizing minus 1. I want to factorize in this case because I want to make this a 7x in the same way like the other form. And we can make this a 7x minus 1. As we see here in both sides, 7x minus 1, 7x minus 1 is a common factor, and we can write 7x minus 1 in this side. And the other side, and we are looking what remains inside. So what remains here, 7x, and here is minus 1. So it's 7x minus 1. So what do we have here? We have the same term. 7x minus 1 times 7x minus 1 is 7x minus 1 squared. So this is a perfect square binomial. So in fact, it tells us that this trinomial was a perfect square trinomial because it gives us a product as a factor. It gives a perfect square binomial. So this method we can solve in a different way. For example, we are multiplying in the same way here like we did in this form, but now we write a little bit differently. We write, so this is a different method, so let me write it with a different color. So we write the x squared minus 14x, and we write this leading coefficient with a constant, which is 49 times 1 is a plus 49. And now we are trying to factorize from this way. We already factorized this form, and we found the factors of 49 and 7 times 7, and minus 7 satisfies this criteria. And minus 7 times minus 7 is plus 49. So now those are the two, and we can factorize now x minus 7 times x minus 7. We can factorize this way, like we are factorizing the trinomials with leading coefficient 1. But now, because we multiplied with 49, now we divide by 49 everything. And if we divide by 49 both sides, it's just the numerical value, just the constant we are dividing. And this is going to be equal with a 6x minus 49 is 7 times 7. 1 7 can simplify with the others and remain minus 1 over 7 in this side. Same thing is going to happen in the other side because these are the same operation. Remains the x minus 1 over 7. But now this is factors in the fraction form. But if we want these factors to be as integers, we can put this 7 in the front here. Same thing we can do in the other side. And now we can write this way: 7x minus 1. It's 7x minus 1. Same thing happened in the other factor, 7x minus 1. As we see, this is the same. The factors are identical, and when we multiply here both of them, is going to be 7x minus 1 squared. So we demonstrated two methods here to solve this polynomial, to factorize the trinomial.